In our last two examples, we want to look at applying rational functions to some real-world scenarios. In example 8, the total cost for a company to produce X units of a certain product is provided by the function below. In this case, C of X is the total cost function, meaning when we plug in a value for X, what we're calculating is the total cost to the company to produce that many units. So if we plug in 100, we know the total amount that it costs them to produce those 100 units. In part A, what we want to find is the average cost function. What the average cost function does is for that same value, say 100, it tells us if we're producing 100 units, the average cost to produce each item. So no longer the total cost, but on average the cost per item. We refer to this as C bar of X. And constructing it is pretty simple. We just take the cost function and divide it by X. So we take that entire function, 945 plus 20x plus 0.03x squared, that entire expression over X. Now what we can do is calculate the average cost per unit at a specific production level. To do that, we'll flip over to Wolfram Alpha and we'll just evaluate this expression by entering 1495 everywhere we have an X. And we get a result of 65.482, etc. So when we evaluate C bar of 1,495, we get a result of 65.4821, etc., etc., etc. And since this is a dollar amount, this would round to $65.48. What we're saying then is when we produce 1,495 units, we paid on average $65.48 per individual unit to hit that production level. In part C, we want to use Wolfram Alpha to determine the end behavior of this average cost function. And then in part D, we're going to interpret that result. Now what we'll do is go back and replace those values that we plugged in with X's, or we could just retype the expression. And in front of that, we'll type in end behavior. Wolfram Alpha is going to give us some information that looks a little bit different. It's using some calculus notation that we haven't gotten into. But under that LIM notation, which stands for limit, what we're going to see is X approaching 0 is actually the first one. But what we want is in the second group, X approaching negative infinity and X approaching positive infinity, with those two results respectively being negative infinity and positive infinity. So as X approaches positive infinity, C bar of X is approaching positive infinity, and as X is approaching negative infinity, C bar of X is approaching negative infinity. In part D, we're asked to interpret the end behavior, but really all we're going to do is look at interpreting this first statement as X approaches infinity, because the second statement has no real practical meaning. If X is production level, X can't be negative. We can't unproduce items or whatever that negative X value would indicate in this case. So we have the end behavior at both ends, but we're only interested in X headed to infinity. And to interpret this, we could say as production increases, which is implied by X approaching infinity, the average cost per unit will also increase. And we know that because C bar of X is headed to infinity. So if we continue to increase production, we're also going to continue to increase the average cost per individual unit to produce.